equals, there we go. Okay, so thank you. So y equals, and now I'm going to switch my x's and y's. So everything that was a y becomes an x and vice versa. We change them all. All right, so we've changed everything. All right, anybody remember what the next part is? What do I do? Okay, and this is the tricky part, okay? I really need you to be paying attention here because I know what somebody's going to try to do. Somebody is going to say, okay, I got to solve for y, so I'm going to bring this over here, which is exactly what you want to do. You want to multiply this over to here. So you'll have 7yx plus 2x equal to 3y minus 8. Thank you. Now, don't write this down, because this is going to be the mistake now. You're going to say, or somebody's going to say, all right, I'm going to add 8 to both sides, and then I'm going to divide by 3. Please don't be writing this down, because it's wrong. Can you tell me what's wrong with that? We were supposed to be solving for y. I did. I got y by itself. Why is that not right? There's a y on the other side. So, what in the world are we? This is wrong. This will not be the right answer. That will not work. What in the world are we going to do if we've got this mess right here and we have to get y by itself? Any ideas? What? Congratulations on selling so many raffle tickets, by the way.
Can we divide by y to get x and then plug x in?
Okay, that's a good thought. The problem is when we divide by y, we're going to end up still with 2 y's in the problem. We're going to end up with a y here and with a y here when we divide. So let's think about this. What if I did some rearranging? What if I moved this guy over here and this guy over here? In other words, what if I made it look like this? Now, I didn't do anything except rearrange. Can you see what I did? Now, there was a method to my madness. Notice now both of the terms with a y are on the same side. And the things on the other side don't have y's. So that's how I rearranged, to get all the y's together on one side and everything else on the other side. Now that I have them both on the same side, I'm going to factor it out. So instead of having 2 y's in the problem, how many do I have? That's wonderful. Now I'm going to get it by itself. What will I do? Last step to get it by itself. I'll divide. So y equals negative 2x minus 8 over 7x minus 3. All right, let's try another one like that. It's just a little more arithmetic than we like to do. But let's say, let's have 5x plus 1 over 3x plus 4. Let's see if we can go through the steps. Our job is to find the inverse. Okay, that's what we're doing. We're finding the inverse of that function. Okay, so here we go. Step 1. Switch the variables. So x equals 5y plus 1 over 3y plus 4. Step 2. Well, solve for y, yeah, but how do I do that? How am I going to accomplish that? Multiply for the fractions, so I'll have 3xy plus 4x. So bring this over here. Now what? rearrange so the y's are on the same side. Very good. Nothing, that's just simple. That's just rearranging the terms so all the y's are together. And then factor out the y. And then divide. So your inverse, the inverse now, is 1 minus 4x over 3x minus 5. Would you agree with that? All right, I'm going to just point something out real quick. This looks like a problem like we had on our last test, where you had to tell me the vertical asymptotes, the horizontal asymptotes, and the holes, right? All right, so let's look at that for a minute. Where is the vertical asymptote in that problem? Little review here. Where is the vertical asymptote in this problem? Well, what makes the denominator 0? So what would make this denominator 0? Negative 4/3. So my vertical asymptote is negative 4/3. All right, what's my horizontal asymptote? Y equals 5/3. Good. The powers match, so I just look right here, right? Now, let's look at the inverse real quick. Tell me about the vertical asymptote of the inverse. What makes the denominator 0? X equals 5/3. What about your horizontal asymptote? Now, I got it backwards, so be careful. What's my horizontal asymptote? Oh my gosh. This is not coincidence. Does that make sense to you? Sure, because what do inverses do? Switch the x's and the y's, right? So if we had x equals negative 4/3, that's going to become y equals negative 4/3. Isn't that cool? I think so. Okay, all right, that's good. Let's get our packets out. And, oh, wait, there's one more thing I need to do. I need to go to your book, and we need to make sure you are clear on what problem number 28 means in section 1.5. So that is page number 136. Page number 136. And the problem says, there's nothing tricky or fancy about this. I just want to make sure you understand what you're supposed to do in this part of the assignment. The problem says, confirm or prove or show that these two things are inverses. Okay? Now, there's what we call a quick proof, and then there is the actual proof. If I'm taking a quiz and I don't have much time and I want to check to see if these are inverses, a real easy thing to do, and we've talked about this, I think, a real easy thing to do is to pick a number like, I don't care, let's pick, how about 9? If I put 9 into this function, and there's nothing special about 9, I just picked it so I got an even number. If I put 9 into this function, what comes out? 3. Now I'm going to step over here and I'm going to put 3 in this function. What better come out? 9, does it? Okay, now why does 9 have to come out? Because if these are inverses, the ordered pairs are switched, right? So if I put 9 into this one and get 3, then I better be able to put 3 into this one and get 9. Now, that is a quick check. It's going to work 95% of the time. But there could be that weird problem where you put 9 in and get 3, and you put 3 in and get 9, but if you put 6 in and get 7, you can't put 7 in and get 6. In other words, there could be something special about the numbers you picked. So this isn't considered an absolute proof. This is a very good check if you don't have very much time. These problems are asking you to do the absolute proof, to do the actual proof. And what that means is evaluate this composition, and we know how to do that. You did it on your test. We're going to evaluate this composition, and we're going to evaluate the composition in the other order. So we're going to do both of these. This is how you prove things are inverses. So that set of problems, when you do your homework, maybe you've already attempted it, when you're asked to prove that things are inverses, you build these compositions. All right, so lots of review today. What does this mean? This means plug G into F. So we're going to find F of 4x minus 3. We're going to plug G into F. So that will be 4x minus 3 plus 3 over 4. I'm plugging G in right here. What's that equal?
X.
Equals just X. That is beautiful, people, because what did we start with? X. So these two functions undid each other. We put an X into G, it did something. We put that answer back into F, and it gave us our X back again. All right, let's try this one. This means plug F into G. So we're going to find G of F. So now we're going to take this and plug it in here. So we have 4 times x plus 3 over 4 minus 3. What does that equal? Don't get freaked out. Don't these cancel? What do we got? X. That's your proof. If you don't get X both times you do this, then you either made a mistake or you don't have the inverse. This is how you prove things are inverses. You build the compositions and end up with X. Everything should cancel out.
So on a test, you're going to ask for actual proof?
Oh, I might. Yeah. Okay. All right. Now, what I want you to do is get your packet out. Have we done anything on this packet yet? We have not. All right, we're going to start right on the front page then. It's an old quiz. Yeah, it's your 1517 packet that I gave you the other day. Front page says it's a be amazing today, it says. I don't know. I mean, I handed them out. I don't know. They're in the first column over there. Bottom of the first column. Okay. So we ought to be able to do everything on here now. Oh, look at the last question. That's what we just talked about. Well, let's start at the top. This is some review of what we talked about last week. It says eliminate the parameter and write as a single equation, a single Cartesian equation. That is an equation in only x and y. So what is a Cartesian equation? An equation with only x and y. Who remembers how to do this? Okay, I know I handed these out. When the extra copies are gone, they're gone. You'll have to figure it out, people. All right, what do we do here? Oh my, we talked about this. These are called parametric equations. How do we... Okay, one option is to set them both equal to t. Blakely, would it be okay with you if I only set this one equal to t and then took that and plugged it into the other equation? That would work too. If I solve for t here, I'm going to get fractions, which is no big deal. I just don't want to do it. So she said get this t by itself, so that's what I did right here. And then I'll take that value and plug it into my x equation. So I'll end up with this. Now, look at that equation. I'm going to clean it up a little bit. But what are the variables in that equation? Okay, see how I got rid of the t? That's called eliminating the parameter. It's gone. So I'm just going to clean it up a little bit so it looks a little bit like a normal equation. There you go. Now, certainly there are other ways you could write that. This is a line, right? So if you wanted to write it as y equals mx plus b, get y by itself, that would be okay too. This just doesn't look very good, so this is called standard form, so it's fine.
Why did it go from 4y to
What?
It went from 2 plus 4y to x minus 2y.
Oh, it should be 4.
Sorry.
Sorry. You're right, that should be a 4. Yeah, just magically change numbers. Yeah. Thank you. All right. Now, number 2. Is the inverse of the log function a function, why or why not? Well, first of all, what does the log function look like? Yep, I saw Libby over there do it. It looks like this. That's my log function, right? Now, this question is its inverse a function? Now, we talked about this the other day. How do you tell if the inverse is a function? Now, the vertical line test tells me if this is a function. What tells me if the inverse is a function? The horizontal line test. So does this pass the horizontal line test? Yes. So what's the answer to the question? Is the inverse of the log function a function? Yes, because it passes the horizontal line test. Now kids, think about it for a minute. If a curve passes the horizontal line test, that means that no y's are repeated. Okay? So this is the horizontal line test. No y's are repeated. Now, what does that mean for the inverse then? If no y's are repeated here, then no x's are repeated in the inverse, and that's why it would be a function. All right, try number 3 on your own. We just practiced a couple of these. See if you can remember the steps to finding the inverse for one of these more complicated problems. Don't forget the first step. You need to switch your variables. match me? Anybody match me? Anybody matches? Anybody have an issue? Easy enough. Next time we're together, whenever that is, we had a quiz and I asked you to do that. Everybody get it right? Okay, turn it over. This is now the next little section of stuff we have to talk about. But some of it is review. We've already discussed some of this. At the top of the page, there is some random picture. Not one of your BFFs, just some random shape that I have created. Okay, that's got kind of a half semicircle or a half a circle above, and then this triangle, and then half a circle below. All right. Now, question A says we're going to sketch this. So we're going to do some things to that picture. Now, everybody in this room knows what that guy right there is going to do. Look where he is. That one is stuck out here. It's not with the X, it's stuck out here. So what's that going to do? Shift it up 1. Now, do you remember what this negative does? We haven't spent as much time with negatives. What do negatives do in general? Adding and subtracting moves you. What do negatives do? Flip you. And when you put the negative on the X, changing the sign on X, it flips you across the Y-axis. So that negative changes the sign on X. You go from a positive X to a negative X. You change the sign on the X, you flip across the Y-axis. So we're going to take that picture and do two things to it. We're going to flip it across the Y-axis, and we're going to move it up 1. Now, some people can do that all in one step. I cannot. So I am going to do one at a time. I'm going to do my flip first. So I'm going to take that picture and I'm just going to flip-flop it. So see that circle right there? He's going to be over here now. That triangle is going to be over here. And that circle is going to be over here. Now, I'm not done yet, but I did this. Can you see that? I flip-flop my picture across the Y-axis. Now, I'm going to take each of those points and pick it up 1 unit. So my circle will look like that, my bottom half of the circle. The triangle will look like that. And my other circle will look like that. So the green is the final answer to the problem. Now, if it works for you to do it all at once, that's fine. If you want to do it in steps like this, just make sure I know what your final answer is. Either use a colored pencil or erase the original, whatever. But make sure I can tell. Is that okay with everybody? All right, let's look at B. B is another situation where we are adding or subtracting. Anytime you are adding or subtracting, you are simply taking the picture and picking it up and putting it down somewhere else. So notice where we're adding. Do you see how we are adding inside the parentheses with the X? So what does that do? Sideways, right? And it's the opposite. So if it's X plus 2, you're really going to back it up. 2. So you're going to take every point on that original picture and you're going to move it back 2 units. Go back to the original. So see this circle right here? That? He's getting moved over 2 units. So he's going to be over here like this. is over here like this. And then my triangle that was over here is now over here. He got shifted over 2 units. And there we go.
This is for.
Yep.
Thanks, stop recording.
That's not good, because this is the part I wanted to record. Oh, no, I think it's still recording. It just put up a reminder on there, because I have to do NWEA testing. Thank you, though, for keeping an eye on it for me. All right, is that okay with everybody? All right, it's the next one now that is new and exciting. We've talked about adding and subtracting, and we talked about negatives. Now, look at problem C. It says 2f of x. That is not an addition. That is a multiplication. So far, nothing we have done has altered the shape of the curve. Would you agree with me? We've reflected it. We've moved it, but the shape has stayed exactly the same. When you put a multiplier into your problem, it's going to change the shape of it. This one is going to become 2 times as tall. Whatever number you multiply by out here in front of the problem, it's what's called a vertical stretch. It's going to make it that many times, whatever that number is, it's going to make it that many times as tall. So if it were a 1/3, it would make it 1/3 as tall. So go back to the original picture. Now, see this triangle right here? He's 2 units tall in the original. So now he's going to be 4 units tall. Everything gets doubled in the vertical. This is a vertical movement. Everything gets doubled in the vertical. So this little circle right here that goes down 1 unit, he's going to go down 2 units. He's still a little circle, but he's going down 2 units. And likewise, that one is going to go up 2 units. So everything in the picture is stretched. It's twice as tall as it was before. Okay? Now, I don't know if there's any room, maybe up here. Let's do an extra problem right up here in the corner. You have a little bit of room. What if the problem had been, draw yourself a little grid up there. What if the problem had been this? Now, I still have a multiplier, right? But that multiplier is in a different place. Does everybody see that? So its impact is going to be different. Anybody want to take a wild guess what that 2 is going to do? It's hooked to the x. And what do we know about things hooked to the x? It's always the opposite of what you think. Remember when it's x plus 2, you actually go backwards? It gets half as big. This is a horizontal. That's a horizontal, and it's going to be half as wide as it was before. Put a multiplier on the x, and it actually divides. It doesn't multiply, it divides. So we're going to divide by 2 instead of multiply by 2. So this triangle that was 2 wide, now I'm looking at width now, not height. This is 2 wide. Now it's only going to be 1 wide. And the circle here, the bottom circle, that was 2 wide, will only be 1 wide. It's still 1 deep. And likewise with the other circle. Okay. All right, would you, on the very next page of the packet is another quiz. Would you turn to the back of that one? There are some more graphs to do. All right, here we go. Got a new shape, all the same ideas, but a brand new shape. So here's the original. Let's see. All right, so there's the original. All right, what does A say? What am I going to do in problem A? Move it 1 unit to the right. So I'm going to pick that picture up. I'm going to draw that exact picture 1 unit to the right. So every point is getting moved over 1 unit to the right. Everybody with me with that? So I'm going to start it here. And there it is. Okay. All right, now we've got B. Now notice where the negative is. It's in a different place than our last problem. Remember when the negative was there, what did we say that did? This is across the y-axis, right? How about a negative where this one is, which is out in front of the problem, not on the x, but out on the whole problem? What do you think that's going to do? Upside down. That's going to flip up and down. That's going to be an upside down picture. So you're going to draw the exact original picture, except upside down. So this V will look like this, and this one will look like this. The thing is just flipped upside down. Everybody okay with that? Oh my golly, look at the next one. This is our last transformation. We've talked about how to add and subtract. We've talked about negatives, and we've talked about multipliers. Now we're talking about what happens when you take the absolute value. Now, you might want to take some notes here, because we're going to do both of the absolute values. This is the one that's on the paper, so we'll do that one. But I also want to do this one, because that's the other way we can take absolute value. We can take the absolute value of the whole problem, or we can take the absolute value of just the x. And it's handled differently. Okay? Now, here's how we do just the x. Write this down. Take notes so you'll remember, because we're almost out of time. When you take the absolute value of just x, recopy everything on the right side of the picture, just as it is. So I'm going to just recopy the right side of the picture, not changing a thing, there it is. Whatever is on the right gets recopied. No matter what it is, the right side of the picture gets recopied. And the left side of the picture is ignored. And instead, the right side is reflected back over onto the other side. So that would be the answer. So let me go through that again. You recopy the right side, and then you reflect it onto the left side. What was on the left side is gone, because in this setup, there can be no negative x values. Whatever you got at positive 2, you're going to get at negative 2. There are no separate negative x's, so this just disappears. And it's replaced by the reflection of the right side. When you take the absolute value of just x, you draw the right side of the curve and reflect it across the y-axis. That's it. Now, when you take the absolute value of the whole thing, it means everything has to be positive. So if it's already positive, you just redraw it. So I'm going to redraw that again. But if it's negative, what happens to negatives when you take their absolute value? They become positive. So everything stays in the picture, but if it's negative, it gets folded up. When you take the absolute value of the whole function, positives stay positive, negatives get folded up. So anything down here is going to get folded up. Anything that's already up there is going to stay put. That's the picture of the absolute value of the whole function. Okay? Now, let's see if you get this. What would this look like? All right, we'll stop and think. What does the original look like? This is the original, right? Now, when I take the absolute value of the whole thing, what happens? The positive part stays positive, but the negative part gets flipped up. So that would be a picture of this. The positive part stays positive, and the negative part gets folded up. What if we did this? Here's the original. Who can tell me how do I draw the picture when I take the absolute value of just x? The right-hand side stays the same, and then what happens on the other side? The right hand gets reflected over. So this would be the picture of ln absolute value x. The right side of the picture stays the same, and it gets reflected onto the left side.
So you would still leave those negatives on there, on the picture?
Yes, because this doesn't have anything to do with negative y's. This is the one that takes the y's out. Someone saying something important?
heavy now.
Maybe.
Oh,
I
that's so
hope.
nice.
Yes.
You do. Jim went and stands up and looked in there. I still have 3 cupcakes left. If anybody wants a cupcake, bye. Have a good day. Bye. Have a wonderful day. I don't know if you noticed your tests are in. I don't know. All right, now I think we have flex now.
Yes.
Which means I can NWDA test.
If you need to loan your iPad for the NWA, do you need to go to the library?
Yeah, you need to go somewhere. Yeah.
Alright.
Hurry up.